All right. Let's continue with our asynchronous discussion. I have a problem here. More examples on how we're going to use the cheat sheet. From now on, I think I have to use the word um, may be the products. May. We will not be saying that these are really the products because let's just leave the mechanism to the chemist because there are really details on this one. So you might be saying that I'm wrong. Well, there are details. So what I will be presenting are just the possible products of reaction. So the first one is predict the major products of nitration of bromobenzene. So again, by just using the cheat sheet without memorizing. So our aim here is just to understand the chemist, not to be the chemist ourselves. But anyway, if you really want to dig deep, you can just look for an organic chemistry text. Okay, so nitration of a bromobenzene, we will first start with, of course, drawing what is a bromobenzene really. So from our previous discussion, we know that bromobenzene would have that benzene ring. Let's first draw that benzene ring. Of course, you must know how to already to draw this one without even using a cheat sheet. But if ever you cannot, then you may still need use the cheat sheet. But it will take too long. It's our basic. This is benzene. Then we will put a bromobenzene. So we have a bromobenzene. So this is a bromobenzene. And then the problem states that what is the major products. So I will rephrase, of course, the word predict the possible major products. Okay, because there are details again to this. So that our answer would be somehow on the right context, but really not how the chemist thinks. Okay, so this is a bromobenzene, and then nitration. We will go to our cheat sheet. Our cheat sheet. We will look for that word nitration, fluorination, bromination, chlorination. There is nitration. Your nitration cheat sheet says that you react it with a nitric acid, HNO3. This one is a nitric acid, of course, with in the presence of sulfuric acid. But anyway, we're not concerned about that. We're only concerned that we know how to use the cheat sheet. So for nitric acid, you will see that the reaction will have a NO2. Of course, we don't have the mechanism. You can look for the mechanism of this, of course, if you want to dig deep. But our concern is for benzene, NO2 will just be added from the ring of benzene. But basically, as I was reviewing, there is a somewhat simple rule. If ever you have already a substituent from your compound, especially for your benzene, uh, it will, but anyway, it will usually form how many kinds of products? I think there would be three. One, two, three. Because if you will attach, so let's paraphrase. So that is, you would have a possible product would be, of course, let's first draw. Uh, that bromine would not be changed from that chemical reaction per cheat sheet, but the nitration, the nitrate, the NO2, as you can see, nitration would yield an NO2. See here, so that would yield an NO2. If this is your bromine, our possible products, of course, might be, of course, there is really a product for this, but we will avoid the details. So an NO2 might form here, or might form here, or might form here. Okay? If an NO2 will form here, it is the same as, no. NO2 might be like this. Another one, I think I have to draw all of them. The possible products. Again, this bromine. You could have an NO2 at this junction. Okay? NO2 at that junction. If you draw an NO2 in this junction, then that compound is still the same as this. Why? Because again, you can name them and it will really have that name without ambiguity. Because of course your organic compounds could just flip. Okay, because they are usually in liquid state, or they are usually in a liquid environment or water environment. Okay, you have NO2, or probably this one is a uh, ortho. Ortho, this is one two ortho. This one is a meta, and another guy would be of course a para. Para. Para lang po, sabi ng chopper. So, a para. So, ortho, meta, and then you would have a para. Sorry, an NO2. So, if we will name this one, this is um, NO2 is nitrobenzene. Yes, that's the nitrobenzene. So, you could name this as 1. This is 1 bromo. 1 bromo nitrobenzene. Nitrobenzene. Our nitrobenzene would now be the parent from our nomenclature. This one, you could replace 1 because bromine would be, bromine, that would be 2 because we will start our number 1 with the nitro because that is the parent. So this compound here is a 2 bromonitrobenzene. This other one would be a 3. 1, 1, 2, 3. So that would be a 3 bromo, bromonitrobenzene. Of course, the 3 would goes to your bromine because that would be the substituent because your NO2 and benzene would be the parent. So another convention of naming this from a UPAC, we could use, of course, the 1, 2. This is 1 and 2, so that could be an ortho. O. So O for an ortho metapara. That is an ortho bromo nitrobenzene. Okay? And then this one would be a meta bromo nitrobenzene. And the last one, of course, is a a para, or a 1,4, 1,4, or a 4, 4 bromo, para bromo P, just a small p. The capital would be the bromo. But anyway, in other books, all of these are small letters, bromonitrobenzene. Okay, so those are the possible products. Again, there is really a product for this, but we will leave the mechanism to the chemist. Our only aim here is to somewhat understand them when they talk about chemical reactions at benzene, because that's how we will have more in-depth knowledge of chemistry, really, to know the chemical reactions. Anyway, I have to cut the video so that it will not be long. Thank you guys.